solving inequalities today. Before we actually solve some inequalities, let's do some warm up to see, do you already understand what an inequality symbol really means? So can you answer the two questions in red? It says label the following as true or false. The first one, if I'm reading it to you, would read 6 is less than 12. The second one, if I'm reading to you, would be -6 is less than -12. Go ahead on your own. Answer both of those as, are they true or false? I'm going to walk around and see how we think about these already. All right, guys, I'm seeing a lot of good things as I'm walking around of people who were able to answer it. Mario, what did you answer for the first one? True, 6 is definitely less than 12. And Janine, what did you answer for the second one? No, this is false. Owing someone $6 would not be worse than owing someone $12. That's probably how you guys were first taught negative values, kind of owing somebody. So let's continue looking at inequalities. So getting started, consider the inequality x is less than 6. What are values for x that make this statement true? Caroline? Anything less than 6. So give me an example of something. One would work. Allison, what would be another one? 2 is a good one. Ooh, what are you saying, Mario? -3, she's looking at negative numbers. Can someone give me a decimal? 5.9, that would work. How about 5.999999999 if I stood here forever and just kept saying nines? That would work, right? How long would it take us to actually list everything that makes this statement true? Far too long. We'd be here forever. So for that reason, when we're working with inequalities, we often show a picture of what the answers look like. And how do we show that picture? Using a number line. And that's really due to the fact that we can't list these numbers. They go on forever and ever. So let's go ahead and see, do we know how to graph x is less than 6? Would we have an open circle or a closed circle at 6? Open. And do I shade to the left or to the right? To the left. Those would match numbers like -3, 1, 2, 5.9, everything else. Do you guys remember that trick from Friday where if the variable is on the left, then the symbol will make an arrow towards the direction that you should shade? So that only works if the variable is on the left. But if you forgot that and you're ever confused about how to shade, that's a nice thing to remember. I'll even write it again. When the x is on the left, shade in the direction of your symbol. Example, x is less than, shade that way, 6. So what if it's 2 numbers, like x is in between? You can only use this when x is on the left. So if x is on the right, then you actually have to shade the other way. And if x is in between, we're going to really focus on those tomorrow. That's called a compound inequality, which means x has to satisfy 2 conditions. But we'll look at more of those tomorrow. Okay, some more vocabulary that's important for you to know that will be helpful in solving today's lesson. The solution of the inequality, you guys gave me some of those. They're the number, or really the set of numbers that makes the inequality true. You guys, I know you know what the solution is because you already gave me some solutions. You said like 5 and -1 and anything less than 6. So let's go ahead and start with example 1. Solve the inequality, graph the solution, write your answer in interval notation. When you're solving an inequality, you want to solve it basically as you would a typical equation. So what would you guys do in a typical equation format? What would you do with the 8? Good, distribute. So we'll distribute that through. And that will give us 8x minus 40 is greater than or equal to negative 16. And my computer is crashing. There's my video. Sorry, guys. Yep, there they go. Okay. And we would solve like we would in a typical equation. So what would we do with the negative 40? Add it to the other side. What's 40 plus negative 16? Nice, Caleb. And then what undoes multiplication? Division. So we're going to divide by 8, and we'll get that x has to be greater than or equal to 3. We want to make sure we know how to represent these solutions visually. So would I have an open circle or a closed circle at 3? Closed. Would I shade to the right or to the left? To the right, because I need numbers bigger than or equal to 3. Now, can someone raise their hand and tell me, how would I write these answers in interval notation? That's that notation you guys used in your homework last night with the brackets, the parentheses, the infinity symbols. How would I write that? Michaela?
It'd be 3 with a bracket and then infinity with a parentheses.
Nice, comma, infinity with parentheses. Michaela, why did you put a bracket instead of parentheses?
Because the bracket means
Well done. Yes, the bracket represents the closed circle. Awesome. Katie?
say it was -3, would the infinity go before?
The only time the infinity comes before is if it's shaded this way.
Yeah, that's right.
Yes, because then the smallest value x could be would be negative infinity.
And then like negative.
It would be negative infinity to -3 with a bracket. Good. All right, guys, on to example 2. Example 2, solve the inequality, graph the solution, write your answer in interval notation. So what would you guys do first? Good, distribute the 3. So we'll do that. And we have -2x is less than 3x minus 15. What would you do next? Subtract the 3x. What's -2x plus -3x? -5x is less than -15. What undoes multiplication? Division. Now let me say this pretty loudly. I'm going to divide by a negative. I'm dividing by -5 in an inequality. If you've learned this before in Algebra 1, there should be something sparking your memory about dividing by a negative. Now 3 people know it. Let's see if we can get half the class to know it. Turn to your partner and see if your partner remembers. What do you have to do when you divide by a negative? Olivia, do you remember?
I think it's you flip the sign.
Yeah, nice. Well done. All right, raise your hand for road to excellence for you and your partner. What do you have to do when dividing or multiplying by a negative in an inequality? Allison, flip the sign, flip the inequality sign. So this tells us x has to be greater than +3. Nice. All right. If you didn't remember that, or some people are telling me they've never learned that before, I have it in a box here, and it's really important that you know it from here on out. It was in a box. Now I have to find it. There it is. Whenever, actually, let's add to this. What must you do when dividing or multiplying? Either one. If you, yes. So when dividing or multiplying by a negative in an inequality, answer, you have to remember to flip the inequality sign. This is something that typically was taught before Algebra 2, but I'm finding maybe due to COVID, some people are forgetting this more this year. So if you've never heard this before, star it, commit it to memory. It will come up over this entire week. Now let's make sure that we can put our answers on a number line. Yes, because this is 1.7a, and tomorrow is the only content that will not be on the quiz. Okay, should we have an open circle or a closed circle at 3? Open, should I shade to the right or to the left? Let's look at our symbol. X is greater than 3. Which way is the arrow pointing? To the right. Can someone raise their hand and tell me what would the answers to this look like in the interval notation? With those parentheses, with the brackets, with the... Katie? Nice. Well done, Katie. Okay, here's the thing. If you forgot to flip the inequality symbol, one of the things I love about math is you can often check your work. Do we know how we would check with an inequality symbol or with an inequality? What would I check? X. What value of X? Well, should 3 be a solution? No. What number should be solutions? Anything bigger than 3. So if I check, for example, I could check X equals 4. Where would I check it? Well, 4 is greater than 3, but to make sure you got the whole problem right, yeah, you're going to plug it back into the original. So I would ask, is -2, let me put it in black print, is -2 times the value of X, is that less than 3 times the value of X minus 5? So if I plug in 4 for X, this better make the statement true, otherwise I have the wrong answer shaded.
Wait, even if you multiply, you're supposed to send,
If you multiply both sides. So not just multiplying in an inequality, but if you multiply both sides,
then you switch.
then you switch the inequality symbol. So -2 times 4 is -8. 3 times -1 would give me -3. Is -8 less than -3? Yeah, that's true. So that means 4 should be shaded. If I forgot to flip the inequality symbol, I might be checking a number like 0, because that would be shaded. And 0 will not fit here.
Don't you distribute it to like the -5? Or
Distribute what?
the -5.
Well, here we just want to follow our order of operations. So we would do the parentheses first, which would be -1. And then we times it by 3. If you just,
Sorry, I thought they were both negative. So,
that's okay. If you just, even if you distributed though, it would work out here. You'd get 12 minus 15, which would still give you -3. All right, good stuff. Let's flip it to the back. Yes. Back page, solve the inequality, graph the solution, write your answer in interval notation. We looked at in the last unit what you could do to get rid of all the fractions in one single step. What is that step that will help us get rid of all the fractions? Yes, I was going to have someone who raised their hand, but good job, Haley. That is it. You want to do what? You want to multiply by the least common denominator. John, do you know what the least common denominator would be in this situation? Nice. Okay, guys, so we're going to multiply both sides of the inequality by 6. We have to keep it balanced. We need to make sure to distribute it in. You might want to put 6/1 since we're multiplying into fractions. So let's start with the first one. How many times does 3 go into 6 evenly? Twice. So I have 2 times 4 plus how many times does 2 go into 6 evenly? 3. So I have 3 times X is greater than, and then we want to distribute here. How many times does 6 go into 6 evenly? Just once. And then I have 6 times X here. All right. If you could turn to your partner. And the person who said the most beautiful place that they've been to is the furthest away from here, Illinois. You share what you would do to finish the problem.
That's you.
Yeah, I guess that's me because it's Aruba. Okay.
Where is Aruba located or whatever?
It's in the Caribbean, which is
Oh, okay.
further away from Florida, I know. Not great with geography, but I know that it's a longer plane ride, so know that. Okay, so we would have 8 plus 3x is greater than 1 plus 6x. And then I would subtract 6x to both sides. Oh, let's not do that. That's going to create a negative. Let's subtract 1 first, which would give us 7 plus 3x is greater than 6x. And then we would subtract 3x, which gives us 7 has to be greater than 3x. And then we would divide both sides by 3, and we get that x has to be less than 7/3. Do you agree?
Yeah, and how do you graph like
Good question. We're gonna talk
fraction
about
properly? Okay.
All right, ladies and gentlemen, you could say this as 7/3 has to be greater than x, or x has to be less than 7/3. Did we get that? Weston? You know what? In fact, what I'm going to do here is show how you could flip the sign. So if I want x to be on the left, so I can use the symbol to tell me what direction to shade, I just have to make sure the point of the symbol is still pointing in the right place. So right now it's pointing towards the x. So I would say x has to be less than 7/3. Is that what you're asking, Weston, why when I switched around? Okay, so these are the same. Now the question is, how do we graph this on a number line? 7 divided by 3. So you could look at that as a decimal, or do you guys remember how to change it to a mixed number? How many times does 3 go into 7 evenly? 2. 2 times 3 is 6. So how many remainders do we have? 1. So it's 2 1/3. It's going to be easier to change it to a mixed number so that you can graph it well. Yes, because now I can see 2 and 3. It has to be, we would just put it a little bit closer to 2, 1/3 of the way to 3. And why did I do an open circle? It's no equal bar. And am I going to shade to the left or to the right? The left, awesome. And then what would be the smallest value x could be? Just so that I can use the arrow as a direction of how to shade.
No, she asked why you switched. Oh, she didn't. Oh. Yeah, I want to know that.
Why the arrow is switched? Just so that I can use the fact that I like to use this as a symbol for telling me which direction to shade. And since I originally had this, I'm just going to rearrange it to put x on the left. So this is the same thing. I'm just flipping it to show me, okay, x has to be less than 7/3. But it's the same thing as saying 7/3 has to be bigger than x.
Oh, okay.
Then guys, well, in interval notation, what's the smallest value x could be? Negative infinity. Where does it stop? 2 1/3. Could I just call that 7/3? And then would I put a parentheses or a bracket around it? Parentheses. And the reason I kept it as a improper fraction is because that's how your book always leaves the answer. It doesn't change it to a mixed number, but mixed numbers are more helpful in graphing. All right, example 4. I want you to try this one on your own. I'm going to walk around, see how we think about this one.
So I had the people also when the x is less than. Wait, when do I have to know? Wait, actually, try. Okay, got it. Plug one.
No, stop. It's good. No, stop.
So what does that mean your answer is for x?
Can you wait till this one new and then
Sure.
this? All right, guys, here is what I saw. One thing that I love is you guys are very good with the distributive property. I saw everybody distribute the 6 and get something like this. Then I saw a few answers. I saw either -13 is less than -12 from some people, or from other people, I saw 0 is less than 1. I didn't see the other solution, but you could have had -1 is less than 0 as well. Now, wait a minute, we have to stop and talk about what that means for our solution. The solution to an inequality are all the values of x that make the inequality true. So what numbers would make this inequality true? Caroline, how do you know all of them will work? Because you tried it. You tried every number or like multiple numbers? Okay. Awesome. So here's what happened. We ended with a statement. Are these statements true or false? True. If you end with a true statement, that means all real solutions will work. We're going to do a check step. If you, in fact, our answer that we need to answer in interval notation would look like -infinity to infinity. You'd have to answer in that way. And if you were graphing your solutions, you have to show an entire number line shaded. -infinity to infinity. Here's why, guys. If you end with a true statement, so if it's true, then you're going to have all real solutions. Here's how you could check it. You can check any number, any real number on the number line. So Haley, give me a number. 3. So I'm going to check, I'm going to call it an example. X equals 3. If I plug it in here, I'm going to ask, is 6 times 3 minus 13 less than 6 times 3 minus 2? 6 times 3 is 18. 18 minus 13 is 5. Is 5 less than 6? Did it make the inequality true? Yes. Is there any real number that you could have given me that would not work? No, because this is a true inequality. Mario.
I thought X is less than -2. Because I did.
Okay, so if you were continuing from here, you subtract 6x. And what is 6x minus 6x? Not x. 6x minus 5x would give you x. But 6x minus 6x will give you 0x or just 0. Okay. All right, guys, let's see if we can do example 5 after doing that one. You need everything that makes the inequality true. In the previous cases, there were only one set. If you end with a true statement, then you're going to have all real solutions. You just have to know if all your variables have canceled out and you're left with a true statement. We've done this with equations before where we just had like 0 equals 0. If it's a true statement, then everything works.
We'll tell if it's like if it's a true statement or you figure that out.
You have to know that. That's the algebra 2 like upper level thought process. Let's see if we can do example 5. Katie. If it said graph the solutions, did it? It did. It said graph the solution, so we should draw a real number line. Just everything shaded. Yeah, just a number line shaded. Caroline? No. Well, infinite technically includes imaginary numbers, and we don't graph imaginary numbers on a real number line. So yeah, or show -infinity to infinity, which is considered to be real numbers. All right, example 5. What are we going to do with the 4? Distribute. So I have 4x minus 12 plus 7 is greater than or equal to 4x plus 1. What is -12 plus 7? -5. What would you guys do next? Subtract 4x, good. And what's 4x minus 4x? 0x, which is just 0. So what is negative wait a minute, what does this mean? -5 is greater than or equal to 1. Is it true? Is -5 bigger than or equal to 1? No, that's false. What do you think that means in this case? Therefore, nothing will work. Yes, no real solution. And if you want, you could shortcut that with a symbol, just a 0 with a slash. But that's really kind of the advanced cases. If everything cancels out and you have a true statement, that means all real solutions. If everything cancels out and you left with a false statement, that means no real solution. Katie, you can't graph it because there's nothing that you can do. Good question. Guys, the last thing, I know we have a minute left. The equations organizer, some people are finding this is helpful for studying for the quiz. For example, on your bell ringer today, you had a quadratic formula, or sorry, a quadratic equation. If you knew this equations organizer well, you would know, oh, I would need to use the quadratic formula if it's not factorable. And here's an example of the quadratic formula. This is filled out to what we should have had filled out online last week block day. So you can utilize this to help you study for the quiz. It's not an actual assignment, but I want to let you guys know it's there. All right.